Hello viewers, welcome to my channel. I'm Hasham Ali Khan. So far 8 problems I have completed on simplex method. Now this is the 9th problem in this video I'm going to explain, and this is the last problem on mixed constraints. So 3 problems maximization model, 3 problems minimization, and 3 problems mixed constraints. So if you want the perfect knowledge, watch all the videos from beginning till end, don't skip in between. And it requires a lot of practice on these problems. The procedure, the manipulation of numbers are more. So it requires some mathematical ability to solve these problems. So before starting the 9th problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Now see the 9th problem. An animal feed company must produce 200 kg of a mixture consisting of ingredients X1 and X2. So 2 ingredients are being mixed up to produce animal feed. So the combined mixture of X1 and X2 should be exactly 200. Then X1 cost 3 rupees per kilogram and X2 cost 8 rupees per kilogram. When cost is given, it means the problem is minimization problem. The problem is minimization. And no more than 80 kg of X1 can be used, and at least 60 kg of X2 must be used. These are the constraints. The first constraint is the mixture of X1 and X2 must be exactly equal to 200 kg. Secondly, no more than 80 kg. That means the X1 ingredient X1 should be no more than 80 kg. That means we can use either 80 or less. And third constraint is at least 60 kg should be there of X2. That means we can make use either 60 kg or more than 60 kg for X2 ingredient. Find how much of each ingredient should be used if the company wants to minimize the cost. Our objective is to minimize the cost. Now let X1, small x1, be the quantity in kilogram of ingredient X1. The ingredient names are capital X1 and capital X2. And how many kilogram of X1 and X2? We have assumed X1, small x1. Small x1 is the quantity in kilogram of the ingredient X1 to be used in order to minimize the cost. Similarly, small x2 is the quantity of the ingredient X2, capital X2, that should be used in order to minimize the cost. So our objective is to ascertain X1 and X2. How many kilogram of X1 and how many kilogram of X2 should be used in order to minimize the cost. So formulation of LPP, objective function. Our objective is to minimize the cost. So minimize cost, Z is equal to, what is the cost per kilogram of ingredient X1? 3 rupees given. And the cost per kilogram of X2 is 8 rupees. So 3x1 plus 8x2. This is the objective. Subject to constraints. The ingredient, the mixture of X1 and X2 must be exactly equal to 200 kilogram. So X1 plus X2 is equal to 200. Already it is an equation. So we need only artificial variable for this constant. X1 is less than or equal to 80. We can make use maximum of 80 kg, not more than 80 kg. So we can make use either less than or equal to. Similarly, X2, at least 60 kg of X2 should be used. That is given in the problem. At least 60 kg of X2. So we can make use either more than or equal to 60 kg. And the non-negativity constraint says X1 and X2 should be greater than or equal to 0. Then introducing the slack, surplus and artificial. Because one constraint is equation, the next constraint less than equal to, greater than. For less than equal to, we need slack variable. For greater than equal to, we need surplus and artificial variable. So here the standard form, objective function minimize, Z is equal to 3x1 plus 8x2 plus 0 into s1 plus 0 into s2 plus ma1. Remember, in the previous video I told you, if the objective is minimize, here we take plus m. If the objective is maximize problem, then we take minus m. Already in the last problem we have done. So minimization problem plus MA1 plus MA2. Subject to constraint, it is already in equation. So we need only artificial variable A1. So x1 plus x2 plus A1 is equal to 200. This is less than equal to type. So we have to add the slack variable. So x1 plus s1 is equal to 80. Third constant is greater than equal to type. So we have to subtract the surplus variable and add the artificial variable. So x2 minus s2, because s1 already we have taken here, so we'll take s2, plus a2, because a1 already we have taken here, a2 is equal to 60. And all the variables x1, x2, s1, s2, a1, a2 should be greater than equal to 0. Now an initial solution is obtained by taking x1 is equal to 0 and x2 is equal to 0. So what we have to keep is like this. We have to keep this a1 is equal to 200, we have to keep. So a1 is equal to 200. Remaining x1 and x2, we take it as 0. Similarly, s1 is equal to 80. So we take x1 0. a2 is equal to 60. So we take x2 and s2 as 0. So all the variables will take 0 except a1, s1 and a2. a1, s1, a2. Remaining x1, x2, s2 is equal to 0. Now we are making the first table. First simplex table is very easy to make because no need of any formula, no calculation. Simply we take the coefficient. Cj value, the coefficient of objective function, basic variable, solution value. Now x1, x2, s1, s2, a1, a2. What are the coefficient of objective function? 3x1, 8x2. So x1 3, x2 8. 0 s1, 0 s2. So s1, s2 0. M, a1 m, a2 m plus m. So here we are taking a1, s1 and a2 as the basic solution. So a1 is 200. S1 is 80 and A2 is 60, right? Now we take the coefficient of the constraints. The constant coefficient 1x1, 1x2. So here 1x1, 1x2. And then A1, 1. So A1 is 1. Remaining all the values 0. Similarly, second, x1 is 1 and s1 is 1. S1 is 1, remaining all the values as zeros. Third constant, x2 is 1. This is x2, 1. S2 is minus 1. S2 is minus 1. And A2 is 1. A2, 1. Remaining all the values as zeros. So we have taken all the values. Now Zj value. Multiply the Cj with the value. So 200 into m is 200m. Plus 0 into 80 is 0. M into 60 is 60m. So 200m plus 60m is 260m. Here m into 1 is m. 0 into 1 is 0. M into 0 is 0. So only m into 1 is m. Here m into 1 is 1m. 0. Then m into 1 is 1m. 1m plus 1m, 2m. Here m into 0, 0. 0 into 1, 0. M into 0 is 0. Here 0, this one 0, this one 0. M into minus 1 is minus m. Here m into 1 is m because here 0, 0. Here 0, 0 and last one m into 1 is m. Right? Now we have to calculate the Cj minus Zj. So Cj is here 3 minus m. Here it is 8 minus 2m. Here 0 minus 0 is 0. 0 minus minus m. So minus into minus will become plus m. M minus m, 0. M minus m, 0. Now the optimality test says all the index row elements should be zeros and positive. If any negative value is there, it is not optimum. We have to go for the next solution. All the values we need zeros and positive. Negative, we don't know whether it is negative or positive. Here we take let m is equal to 10. We can suppose any value for m which is greater than the actual cost. The actual cost is 3 rupees and 8 rupees. So above 3 and 8 you can take any value. You can take 9, 10, 11, 12, any value. But I am taking 10 because easy calculations. So first one, 3 minus 8, 3 minus m. So 3 minus 10 is equal to minus 7. Second, 8 minus 2m. So 8 minus 2 into 10 is 20. So 8 minus 20 is minus 12. Now check. Two negative values we are having. So it is not optimum. We have to go for one more table. So which is the most negative? That should be selected. Most negative is minus 12. We are having two negative, minus 7, minus 12. Minus 12 is the most negative. So this is the entering variable in the next table. Entering variable is x2. x2 will enter in the next table, right? Now which one will depart? It depends on minimum ratio. Now we calculate the minimum ratio. Solution value divided by intersectional element. 200 divided by 1 is equal to 200. Here 0 is the denominator. Should not be calculated. 80 divided by 0 is undefined. So 60 divided by 1. 60 divided by 1 is 60. Now two minimum ratios we have, 200 and 60. Whichever is less. 60 is less. For which variable 60? A2. So in the next table, A2 will depart. In place of A2 we will take x2. So this is a simplex table 2. x2 enters and A2 departs, right? So first A1 as it is, then S1 as it is, and in place of A2 I am writing x2. So what is the coefficient of A1? Here A1. Remember, when A2 is departed, we should not open the column of A2. No need to open the column of A2, only A1. So A1 it is M, S1 it is 0, x2 the coefficient is 8. That's all. So we have calculated this one. Now we need to calculate the values of the entering variable. The values of entering variable. Values of entering variable is equal to, what is the formula? Already every problem we have applied. Values of departing variable divided by intersectional element. What are the values of the departing variable? A2 is departing. 60, 0, 1, 0, minus 1 and 0. We are not taking the value of A2 because A2 is departed. These are the values of the entering departing variable. Divided by, what is the intersectional element? 1. Divided by 1 is equal to 60 by 1, 60, 0 by 1, 0, 1 divided by 1 is 1, 0 by 1 is 1, minus 1 divided by 1 is minus 1, and 0 by 1 is 0. 0, 0, minus 1, 1, 0, 60. Correct. Now, these are the values of the entering variable x2. Right? Now in x2 we will take 60, 0, 1, 0, minus 1, 0. That's all. Now we need to calculate the values of the variable a1. Values of a1 is equal to values of a1. Already you know in the previous problem we have applied the formula. The values of a1 is equal to old value minus intersectional element into values of the entering variable. The old values of a1 are 200, then 1, 1, 0, 0, 1, 1, 0, 0, and last one is 1, minus intersectional element of a1. What is the intersectional element? 1. 1 into 1 into 1 into 1 into 1 into. Values of the entering variable is 60. 60, 0, 1, 0, minus 1 and 0. That's it. So 200 minus 60 is 140. 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 0 is 0. 0 minus into minus will become plus. 1 ones are 1. So 0 plus 1 is 1. 1 minus 0 is 1. So we got all the values of a1. I'll write down here. 140, then 1 0 0 1 1. We got the values of A1. Now we need the values of S1. Values of S1. Old values of S1 are 80, 1 0 1 0 and 0. The last 0 we are not taking A2. So 80 1 0 and 1 0 0 minus intersectional element. What is the intersectional element of S1? Is 0. Intersectional element is 0. 0 into 0 into 0 into 0 into. Now, values of the entering variable. Entering variable are 60, 0, 1, 0, minus 1 and last one is 0 is equal to. Now carefully you see. 80 minus anything multiplied by 0 is 0. So in all this bracket you will get 0. So same value will remain 80, 1, 0, 1, 0, 0. So 80, 1, 0, 1, 0, 0. So we got all the values of A1, S1 and S2, X2. Now we need ZJ value. Multiply. M into 140 is 140M. 0 into 80 is 0. 60 into 8, 480. 60 into 8 is 480. So 480 plus 140M. 140M. This is the value of Z solution value. Now ZJ value. So M into 1 is M. 0 into 1 is 0. 8 into 0 is 0. So M remains. Right? Then M into 0, 0. 0 into 0, 0. 8 into 1 is 8. Here M into 0, 0. 0 into 1, 0. 8 into 0 is 0. M into 1 is M. Then 0. Minus 8. So M minus 8. 8 into minus 1 is minus 8. So M minus 8. M into 1 is M. Remaining 0, 0. Now subtract 3 minus M. Then 8 minus 8, 0. 0 minus 0, 0. 0 minus M minus 8. 0 is the CJ value. ZJ value M minus 8. So 0 minus M minus 8. M minus M is 0. That's all. Now we need to find out optimality test. All the values should be zeros and positive because it's a minimization problem. If any negative value appears, it is not optimum. We have to make another table. Now we check. Let M is equal to 10. The first one, 3 minus M, that is equal to 3 minus 10 is equal to minus 7. Secondly, 0 minus M minus 8. So 0 minus 10 minus 8. 0 minus 10 minus 8 is 2. So 0 minus 2 is minus 2. Now two negative values we got. So it is not optimum. We have to make simplex table 3. The most negative should be selected. Most negative is minus 7. Minus 7 is 3 minus M. So this is the entering variable in the next iteration. X1 will enter in the next iteration, next table. Now which variable will depart? That depends on minimum ratio. Now minimum ratio we calculate 140 divided by 1. 140 divided by 1 is 140. And here 80 divided by 1 is equal to 80. Here divided by 0. 60 by 0 is undefined. So we got minimum ratio 140 and 80. So whichever is minimum? 80 is minimum. So departing variable is S1. In the next table, X1 will enter and S1 will depart in the next table. That is simplex table 3. Now in simplex table 2, we have seen that X1 will enter and S1 will depart in the next table. That is simplex table 3. Now I have drawn simplex table 3 here. X1 enters and S1 departs. So we have opened all the columns x1, x2. As long as a1 is there, we have to open the column of a1 also. Now the only thing is, in place of s1, I am taking x1. The remaining a1 and x2 will remain same. So first we need to find the values of the entering variable x1. So what is the formula of values of departing variable divided by intersectional element? Departing variable is s1. So what are the values of s1 here? 8101, right? Then last one 00, divided by, what is the intersectional element of s1? It is 1. So divided by 1. So 80 by 1 is 80. 1 by 1 is 1. 0 divided by 1 is 0. 1 by 1 0, 0 by 1 0, 0 by 1 0. So we got the values of the entering variable x1. So I will note down the values. 80, 1 0, 1 0 0. That's it. Now we need to calculate the values of a1. The formula is old values of a1 minus intersectional element into values of the entering variable, right? Already same formula we have applied in so many problems. So what are the old values of a1? Here you can see 140, 100. So I have taken 140, 100. Last one 1 1. Here you can see 1 1 minus intersectional element of a1. What is the intersectional element of a1? It is 1. So 1 into values of the entering variable. Entering variable are 80, 10. So 80, 10, 100, all entering. Now 140 minus 80 will remain 60. 1 minus 1, 0. 0 minus 0 is 0. 0 minus 1 is minus 1. 1 minus 0 is 1. 1 minus 0 is 1. So we got the values of a1 here. I'll write down the values of a1. 60, 0, 0, minus 1, plus 1, plus 1. Similarly, we need to calculate the values of x2. Same, we'll take old values of x2. The old values of x2 are 60, 0, 10. 60, 0, 10. Last one minus 1, 0. Minus 1 and 0. Minus intersectional element of x2 is 0. x2 intersectional element is 0. So 0 into the values of the entering variable. Entering variable here the values are 8101. 810100. When anything is multiplied by 0, you will get 0. So in all these bracket you will get 0. So what it will remain? 60, 0, 1, 0, minus 1, 0. These are the values of x2. So I am taking the values of x2. What are the values? 60, then 0, 1, 0, minus 1 and 0. That's all. We got all the values. Now we need to calculate the zj value. How to calculate zj value? M into 60 is 60m. 3 into 80, 8 3s are 24, 240. See here. 3 into 80 is 240 plus 8 into 60, 8 6 are 48, 480. That is equal to 240 plus 480. It comes to 720. So I am writing here 720 plus this 720 plus 60 into m is 60m. That is the value of solution value, zj value. Now m into 0 is 0. 3 into 1 is 3. 8 into 0 is 0. So 3 remains. Here m into 0 is 0. 3 into 0 0. 8 into 1 is 8. Here minus m. 3 into 1 is 3. 8 into 0 is 0. So 3 minus m. Here we will take 3 minus m. Right? Then m into 1 is m. 3 into 0 is 0. 8 into minus 1 is minus 8. So m minus 8. Here m into 1 is m. 0, 0 will remain same. Now Cj minus Zj. 3 minus 3, 0. 8 minus 8, 0. 0 minus 3 minus m. Here 0 minus m minus 8. Here m minus m, 0. So we have calculated the Cj minus Zj value. Optimality test. All the index row elements should be zeros and positive because it's a minimization problem. If negative value is there, then we have to make another table. Now we have to find out whether negative value is there or not. Let m is equal to 10. M is equal to, so 0 minus 3 minus m. 0 minus 3 minus 10. So 0 minus 3 minus 10 is minus 7. So minus into minus will become plus 7. So this is positive value we are getting. If negative appears, then we have to make. This is positive. What about this one? Second one. 0 minus m minus 8. So 0 minus m is 10. 10 minus 8. So 0 minus 10 minus 8 is 2. So 0 minus 2 is minus 2. One negative figure we got. That means this is not the optimum solution. One more table we have to make. If any negative appears, it is not optimal. So here minus 2 is negative. For which value? 0 minus 8. That means in the next table this S2 will enter. S2 will enter in the next table. Right? Now which one will depart? It depends on minimum ratio. So here solution value 60 and intersectional element is 1. So 60. Here denominator is 0. 80 divided by 0 undefined. 60 divided by minus 1 should not calculate. If denominator is 0 or minus, you should not calculate the value. So what is the minimum ratio? 60. So which variable will depart? A1 will depart. In the next table, A1 will depart. So no need to open the column of A1. We don't require the column of A1. We need X1, X2, S1, S2. So which is entering here? S2 enters. So simplex table 4, S2 enters and A1 departs. S2 enters and A1 departs. So now we take the values. Now we take the values here. A1. In place of A1 we will take S2. And in place of X1 as it is and X2 as it is. So 0, 3, 8. Right? Now we take the values of X1. Now we need to calculate the values of the entering variable. Entering variable we have to calculate. So here entering variable, already we know the formula for entering variable, value or departing variable divided by intersectional element. So departing variable is A1. So A1 values are 60, 0, 0, minus 1, then plus 1. We are not taking the value of A1 because A1 is departed. Divided by intersectional element. What is the intersectional element of A1? It is 1. So I am taking 1. It is 60, 0, 0, minus 1 and 1. So here these are the values of entering variable. Which is the entering variable here? S2. S2 is the entering variable and A1 is the departing variable. So we got the values of S2 here. First one. So 60, 0, 0, minus 1 and plus 1. Now we need to calculate the values of other variable X1. We need to calculate the values of X1. So I am writing values of X1. The old values of X1 are 80, 1, 0, 1, 0. That's it. 80, 1, 0, 1, 0. Divided by, minus. Minus. What is the intersectional element of X1? It is 0. So 0 into 0 into. Now values of the entering variable are 60, then 0, 0, minus 1 and 1. These are the values of the entering variable. When anything is multiplied by 0, it will be 0. So same values will remain 80, then 1, 0, 1, 0. So here X1 values are 80, 1, 0, 1, 0. That's all. Now we need to calculate the values of x2. Yes, the values of x2 we need to calculate. Now see carefully. Old values of x2. What are the old values of x2? 60, 0, 1, 0, minus 1. Minus intersectional element. What is the intersectional element of x2? It is minus 1. Minus 1. Minus 1 into values of the entering variable. Entering variable values are 60, 0, 0, minus 1 and last one plus 1 is equal to. Now see carefully. 60. This minus into minus will become plus. 1 into 60 is 60. So 60 plus 60, 120. 0 minus 0 is 0. 1 minus. This will become 0. So 1 minus 0 is 1. 0 minus. Yeah, minus into minus will become plus. Plus into minus will be minus 1. Then here minus into minus will become plus. So minus 1 and minus into minus will become plus 1 is equal to 0. So we got the values of x2. So 120. Then we have 0, 1, minus 1 and last one 0. So we got all the values. Now we need to calculate zj value and cj minus zj. First zj. So 0 into 60 is 0. 3 into 80, 240. Plus 8 into 120 is 960, I think. 120 into 8 is 960. So 960 plus 240 is equal to 1200. So zj value we got 1200. Now here 0 into 0 is 0. 3 into 1, 3. 8 into 0, 0. So 3 ones are 3. 0, then 0, 8 ones are 8. Here 0. 3 minus 8. This is 8 into minus 1 is minus 8. So 3 minus 8 is minus 5. Here 0 into 1, 0. This is 0. So cj minus zj, 3 minus 3, 0. 8 minus 8, 0. 0 minus minus 5. So minus into minus will become plus 5. 0. That's all. Optimality test says all the index row elements should be zeros and positive. No negative should appear. And we got all positive. 0, 0, 5, 0. So we have reached the optimum solution. No further tables are required. This is the optimum solution. So after completing this table, you should write the conclusion. Since all index row elements are zeros and positive, so we reached the optimum solution. The optimum solution is x1 is equal to 80. x2 is equal to 120. And the minimum z is 1200. Therefore, in order to minimize the cost, 80 kilogram of ingredient x1 and 120 kilogram of ingredient x2 should be used, so that the total cost will be minimum. The minimum cost is 1200 rupees. That's all. So this is the end of problem number 9. So totally 9 problems we have completed. 3 problems on maximization type, 3 problems on minimization, and 3 problems on mixed constraint. The last topic in this simplex method is duality. So inshallah we'll start duality in the next video. But my suggestion to my viewers, practice a lot. Simply watching the video only once and only at the time just before examination will just makes you confused. So if you want to perfectly do the problem in examination, you need some practice. Watch the video once, twice, thrice. Make your calculations, increase your speed of calculations. Then definitely you can be able to do the problem of simplex method in examination. So inshallah we'll start duality in the next video.